We want to try to get the integral of secant cubed. You definitely want to break secant cubed into secant squared times secant. What you could try, but is not going to work, is try changing this to tan squared plus 1, distributing, and maybe using these derivative formulas. Turns out it's not going to work, though. So instead, we want to use integration by parts. In other words, we want to use the formula that says the integral of u dv is equal to uv minus the integral of v du. Now, if you have trouble memorizing where the u dv goes and where the v du goes, then you can remember that my ex broke up with me because she said I was negative, very dumb, and ugly. We now have to pick our u and our dv. Our u has to be something that's easy to differentiate, and our dv has to be something that's easy to integrate. Now, as far as integrals go, we actually want to convert these derivative equations into integral equations by getting rid of the derivative on one side and putting the integral on the other. And when we look at what results here, we don't have secant tan showing up in our integral, but what we do have is secant squared. So that means I'm going to let secant squared x be our dv. Now, technically, I also need that dx right there. And for v, you always have to put whatever the integral of that is. And we just said that the integral of secant squared is tan. So now we have our dv and our v, but we turn our attention to our u, and our u has to be whatever's left over. So since we already used up the stuff underlined in pink, now we have secant x is the only thing that's left. So that's going to go over here in our u. And remember, we're supposed to be differentiating. Can I take the derivative of secant x? Well, yeah, sure, because we already know what it is right here from the formula. So we're just going to pop in secant x, tan x right here. Now, technically, whenever you have a du or dv, it always needs to end in a dx, so let's just put a dx at the end of that. Now we just have to plug everything into uv minus integral of v du, and that would be secant times tan minus integral of tan times all that other stuff. I'm now seeing tan and tan, so I'm just going to make that into a tan squared. Now I got to remember the formula tan squared plus 1 equals secant squared, but if I subtract 1 on both sides, I actually get a formula for just tan squared, that it's secant squared minus 1. So let's replace this with secant squared minus 1. We still have our secant right next door. It's now time to distribute, which will get you integral of secant cubed minus secant, which is also equal to integral of secant cubed minus integral of secant. Now, integral of secant, we actually do have a formula for that. It's right here, so we can just pop in the right side of that right there. But then we still need all of this. And let's not forget that we also needed all of this. And there was a minus sign right here. Now that minus sign needs to come down here, but remember, we're minusing what? We're minusing this, which is equal to this. So grouping with parentheses reminds you that you do actually need to put parentheses here, because that's what you're minusing, which means that we now have to distribute this minus sign. And that's going to mean you'll have minus integral of secant cubed plus all this ln crap. And then technically, yeah, it would be minus c, but I'm just going to put that as plus c. That's what you're supposed to do when you're dealing with the arbitrary constant. It's just always going to be plus c at the end anyway. Now we just want to bring this guy down right here. Then we just have one last integral left to do. Wait a second. Integral of secant cubed? That's what we were trying to find. Of course, we don't have a formula for that. But we can say that all of this is equal to the original. And what that does is it gets us an equation where I can now add the integral of secant cubed to both sides in order to cancel it out. And on the left side, I would now have 2 times the integral of secant cubed, which equals the right side. And we're so almost done. We just divide by 2 to cancel out the 2, leaving us with the thing we were trying to solve for. Integral of secant cubed x equals our final answer. Go to boringmastery.com.